So here on these 8 graphs that we've got on this slide, this first one in the top left corner, what kind of parent function is that? What would you give it a name to be? Linear? Can you be more specific than just linear? Anybody be more specific besides just linear? What is it called when it's just a line, a straight line, like either horizontal or vertical? Because if you look at the one below it, what would you consider that? This one is linear. So what's this one here? Okay, we'll come back to it then. How about the one next to that, or the one second from the left?
Absolute value.
Absolute value. How about the third one there on the top?
Square root.
Square root. And that last one there on the top row?
Quadratic.
Quadratic, yep. All right, let's go down to the bottom row. We already did that first one. That one was linear. How about the one next to it?
Cubic.
Cubic. And the third one there?
Exponential.
Mm-hmm. And this last one in the bottom right corner?
Quartic.
Quartic, yep. So we still don't have a name though for this top left one. It's just a horizontal line, more specific than linear. I'll give you a hint, it starts with a C. If something is never changing, it is considered constant. And that is a constant. Now, recognizing those from a graph is pretty easy. What other ways could they give you as far as a representation and then ask you to find key features from it? What other ways, as far as a representation, could they give you and ask you to find a key features for that function? An equation, yeah, they could give you an equation. So if you were given an equation, what would be a good thing to do? Yeah, type it into either a Desmos or in your calculator and find all the key features that way. What's another way it could be given to you?
A table.
A table, yeah. So these next slides kind of give it away for us, but they could give you tables. So looking at a table, how could you decide what type of function or be able to find key features for that function? How could you do that from a table? All right, so if we put, okay, put it in the calculator and then do what?
Find the equation and graph it.
All right, how do you find the equation?
I don't really know. I forgot, honestly.
Oh. All right, so some people forgot. Anybody remember how to find it? Say that again?
Second list, I think.
Second.
You do second list.
I don't think that's where we want to be. Can you guys see that okay? Can y'all see the calculator on the screen?
Yeah.
Okay. I know you guys could. I just want to make sure that they could. How could you do it in a calculator with a table? Where am I able to put in values into my list? Stat, yeah, so we could go into stat and edit, and we could clear these out, and you could put your table values in here to be able to do that. Let me go back to this screen. All right, so that could be one way. We'll talk about more of that in a second. How, could you just look at a table, for instance, like this first one on this second slide here? What kind of function would you think this would be?
Constant.
Constant, and how would you know? Yeah, all the same y, all the way down. So that would indicate that it was a constant function. So looking for patterns is a way in which you can look at a table and try to decide what type of function it might be. Are you familiar with how to put values in Desmos in a table? Maybe, maybe not. All right, so let me pull up Desmos here. If you go to this plus sign in Desmos, you can click table and it'll allow you to type in those table values and it will plot those points. And if it plots those points, what does that do for you? Plotting those points gives you what? It won't give you an equation, but it gives you a
function.
Okay, but what's specific about a function? It could be the slope if it was linear. Doesn't it give you a graph? Or at least an idea of what the graph looks like? So what could you do once you had those values in and you had an idea of what the graph looked like? So I'm just going to type in, I think these are the ones that that first table had. Yes, ma'am. How do I get to the graph in here on Desmos? Oh, so just did you go to desmos.com? And so then you should say, it should say like graphing calculator. Click that little button. I think it's blue. And how did I get the table? Go to the plus sign and select table. So if I just put those point values in, you can easily see what type of function it might be. But looking for patterns is another way to do that. So let's go to this second table on this slide. any kind of patterns here? I'm just going to add in a text box to kind of give me somewhere to type what we're talking about. So this table on the right-hand side, do you see any types of patterns that might indicate what type of function it would be?
It's most likely a parabola because the numbers repeat.
Okay.
9 and 9 at the
So looking at the y values, we're seeing that they're repeating. All right, that definitely indicates it could be a parabola. Why is it not absolute value though? Absolute value like has that V shape, which is kind of similar. Is there a relationship between the x's and the y's that would indicate that it was quadratic?
by 2, you get the y values. So it looks like it's squared.
Okay, very good. Right. So if you take the x values and you square them, you get the y values. So y values repeat, mean it could be quadratic. Relationship between x's and y's indicate the y's are the x's squared. So that could be reasons why. Looking again for patterns in that table. Y values repeating. X relationship there showing the x's are squared, give you the y's. Okay, let's go on to, here's another set on the next slide. Looking at the table on the left. Any patterns there that might indicate what type of function it is? Okay.
I think it's linear because I think it's one of those equations where it's x equals y.
Right. I mean, if you look at them, they're the same. And well, also in linear, aren't, can't you look for like a rate of change that the y's are going up or down by the same value each time as long as so are the x's? Is that occurring here? Yeah,
Yes.
each time you're adding 1 to get to the next value in the table. So we can say there's an increase of 1 in the y's and x's, which indicates it would be linear because it has a constant rate of change. So looking for adding the same number each time among the y's and the x's. Now, it doesn't mean that they have to be the same on both y's and x's, but just that there is a constant increase on both of them would tell you that it's linear. All right, the one here on the right, any patterns?
Is it exponential?
Okay, tell me why you think it's exponential.
Because like, oh shoot, never mind. I'm thinking of the wrong thing. My bad, my bad.
I mean, I didn't say you were wrong.
I don't know. What I had in my head was different than what it said. Like I kind of mixed up the y and x. So my reasoning is not how I wanted it to be. You know.
Okay, that's fine.
I think it is exponential because the y values are doubling.
Yeah, I knew it was exponential, but my reasoning was wrong. So I don't know.
I got you. See, I think I would agree with exponential as well. The question is, like, it's kind of hard to see what the base might be. But since they're all even numbers, what would you say even numbers and their bases or even if I'm looking at the y values there, would you assume that that was probably a even base? What base might it be? Like something to the x power makes it exponential. Could it be like 4? I mean, test it out. If you said 4 was the base and you plugged in 3 for the exponent, is 4 to the third going to be 8? I don't think so. So it could be 4 is the base. What might the base be?
Would it be 2 to the third power?
Yeah, 2 is the base. Yes, so 2 to the third is 8. Is 2 squared 4? Is 2 to the first power 2? 2 to the 0 power is 1. Yep. So this is an exponential with, oh, I can't spell today. Oh. That one could be a good one. I'm going to go back over here for a second where we could put in those values. Oops. So if we put in those values into Desmos in our table, we can see there is a nice exponential curve. So that could help you out there. All right, I got a few more to look at here. What about this table? Square root, very good. Right, and how did you know that? What pattern did you look for? Okay. Is there a relationship between the x's and the y's? Since you said it was square root. Like if you took, right, or vice versa, if you take the square root of the x, it would give you the y. Yeah. So this one is square root because the square root of the x's gives you the y's. Yeah, so looking at the pattern there between the x's and the y's, you take the square root of the x, you get the y. What about the one next to it?
Is that one absolute value? Because like it changes, it mirrors itself, but from negative to positive.
Okay, possibly.
Is it? I think it's cubic because if it's like, for example, I think it's 1 to the power of 3. Like that would be 1, and 2 to the power of 3 is 8, and 3 to the power of 3 is 27. So it's cubic.
So yeah, I could definitely see where it would possibly be absolute value. But the key thing here though is absolute value ever negative? No, if I take the absolute value of 3, it's going to be a positive here, or excuse me, of a negative 3, it's going to be a positive. So that I could see why you might think that, but yes, I think it is cubic. And as far as you said, Yusuf, because you would go 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27. And then you can have negatives when you are cubing something. So is cubic because the y values are the x values to the third power. All right, last one here.
This one's absolute value.
Yep, this one is absolute value. Yes, because these are all just the absolute value of the x value. They're all positive when compared to the x value. Any questions there looking at patterns in a table? I wanted to go back here to Desmos and talk about how you might be able to find an equation if you were given a table. Now this is where looking at it, let me get a better example here. All right, so I want to get a quadratic one, something we're really familiar with. So if you came across a table and you typed it in and you looked at the points and you were like, that looks quadratic, how could you figure out what that quadratic equation was? All right, I'm going to show you how you could do that in Desmos. Now, the key thing, though, is you've got to recognize what type of function you think it is. So we think this one is quadratic. I think it's pretty easy to see. So to do that, in the second equation here, you would type y, and then it's the tilde, which is the shift and the key right next to the number 1. And then it's, what's the typical form for a quadratic? Ax squared plus bx plus c. So we could say a, now I've got to tell it what x's I wanted to use. I wanted to use these x values here. So this is going to be x1 squared plus bx1 plus c. Oops, I forgot the y. Here for the y. So if I type in what I know to be the generic form of a quadratic, it will do the regression for me. And it will tell me what the values of A, B, and C are down here. So if you had had some other different values, right, it could easily tell you what A, B, and C are. But you've got to know by looking at it what type of function it is, whether it's quadratic, whether it's linear. What would linear look like? Let's get something linear in here. So let's say that was our table. I looked at it, I could tell that's definitely a line. Well, I could go y1 tilde. What's the form for linear?
You guys gotta stop talking. So sorry about that.
You're good. You're good. What's that form for a linear one?
Y equals mx plus b.
Yeah, mx plus b, right? So we have the y1, which is telling us, hey, use these y values. Then we're going to have m and x1, because we want it to use these x values that are in our table. Then we'll go plus b. And you can see there, this equation would be y equals 2x plus 8. Any questions there? All right, I know you're familiar. This is probably the way that y'all are used to doing it. We're going in here. Let's type in some values. So we said what? 2, 4, 6, 8, 10, 12, 14. How in the calculator could I see those points graphed? It's like if I just hit graph, I can't see them. Because where did I put these? I put these in stat, right? So I need to turn my stat plot on to be able to see them. Let me clear that out. So here I am at y equals. If I go up and hit plot 1 and hit enter, it'll turn that stat plot on for me. And do you remember what's the zoom number for a stat zoom? Zoom and it's number 9. Zoom 9 will give you your stat zoom. So I can look right there and tell that that graph looks what? Linear. So if I was trying to find the equation for it, after I had that table, all right, this is the other part that maybe you remember, maybe you don't. But you could go stat and calc. And remember, you had all these different choices to try out. So we said that this one looks linear, so that would mean I probably want to choose number 4 here that says linear regression. If your calculator has more updated software, you're going to have to arrow down to where it says calculate. Mine does not. But there, it will tell us, just like it did in Desmos, what the values of A and B are. Any questions on how to do regression? Because that's what we're basically doing. Come up with an equation if you had a table. I've showed you 2 different ways, how to do it in Desmos and how to do it in the calculator. If you looked at a graph and you thought that it might look quadratic, of course you could select number 5. Or if you thought it was cubic or quartic, 6 or 7. If you thought it was exponential, you could select number 0, which would give you exponential regression. So kind of the key focus here for you is there are different ways they can give you a graph, they could give you a table, they could give you an equation and ask you to find the key features. Do you feel like you could do that? Could you come up with the key features if they gave you one of those 3 things, an equation, a graph, or a table?
Yes.
Yeah.
So you're talking about from yesterday, how to write down the positive negatives?
Yeah.
Okay, yeah, sure, we can do one. Here, we'll do it right now. So let's see, let's get a function in here. Y equals 3x to the 4th minus 2x squared minus x plus, no, let's go minus 8. This one work?
Yeah.
Okay. So, hold up. All right, so if we're talking about positive and negative, actually, I want to move it up some so it's not so far down. Let's make it -4. I like that better. And zoom in a little bit easier. All right, so if we're talking about positive and negative, let me get my pen up here. Positive being where is it above the x-axis, negative being where is it below the x-axis. There it goes. So it is above the x-axis here and here. So those would be the positive parts of that graph. The negatives being below, oops, not what I wanted. There we go. Being this is all negative. And we're doing this based on the x coordinates here. So this is negative. All right. Oh shoot. Let me come back to this. Let me click on these so we can see. All right, now we got those back up there. All right, so there I said positive above, negative below. So if I'm trying to talk about where is it positive, hey, we're going left to right. All right, we said this piece here is positive. As I go to the left, it's going towards what as an X value? What is the X value as we go to the left? What is it going towards?
Negative what?
Negative
Wait, wouldn't
infinity?
it be? Yeah, negative infinity and negative 1.167.
Uh-huh. So it's positive there. It's also positive for what? Right here.
1.305 to infinity.
To infinity. And then we've got the negative piece is where it is below the x-axis. And that is this, all this right here, which it is negative starting at this point, which is negative 1.167. And it's negative all the way over to right here, which is 1.305. And so you're just looking at what parts on the X, as far as X values go, is it above and is it below the X-axis? Any other questions, something you want me to go over about key features? Jay, to answer your question, yes, pretty much your homework assignments are all due on Sunday. There are technically a few things that were due yesterday or due today. I'll go back over those again. So yesterday, technically, the create your own and the create your own solutions were due. And then today, you've got to go into the create your own functions document, which looks like this. And as you can see, somebody's already started. They've entered in the answers in the right-hand side here to someone else's problem. And so those are the only two things that were technically yesterday and then today. Everything else homework-wise and activities are going to be due by Sunday. That is correct.